Now the school, and this is your physics. Section A as usual, remember 40 marks. And when you get your paper in hand, you are expected to look at actually section B. And then for section B, you have to look at what are the questions that you can easily get full marks for. So you can see some diagrams here. So you have to read through and then you have to decide which of these 4 questions you are going to attempt. Alright, once that is done, then you have no choice but to come to question number 1 and you have to just start thinking of section A, question 1. So let us begin with question 1. MCQ, first one. The body of mass 4 kg is moving with velocity 4 meter per second. If the mass is doubled and the velocity is tripled, the ratio of the initial and the final kinetic energy. You will need a little bit of working space for case 1 and case 2. Now remember, if this is your page, then you'll write question 1 here, 1 here, and then your thinking step will be here. Okay, so M1 is 4 kg and V1 is 4 meter per second. And mass is double, so M2 has become 8 kg and velocity is tripled, so V2 is equal to 12 meter per second. And then you will have KE1 is to KE2 will be equal to half. Now I'm not writing M1 V1 square, I'll just write here 4 into 4 square is to half into 8 into 12 square. So half and half got cancelled, 4 ones and 4 twos. That will give us 4 into 4 is to here 2 into 12 into 12. So 4 goes 3 times, this 4 goes 3 times, and I am getting 3 3s 9 2s 18. 1 is to 18 I'm getting. Initial to final, that is KE1 to KE2. So what is your answer? D. Bacha, you wrote only the answers later on, forgot to write A, B, C, D. So you got straight 0. And your A should look like A, your D should look like D, your D looks like A. Can you see? Will you consider this as D or A? Your D should not look like A. So if you written like that, you will get a straight 0. So remember, when you write a D, it should be both written. Okay? Then we come to the second part. What is the second part saying? Infrared radiations are not used for. They are for this, yes, because of the heating effect. They are detecting fake currency and diamonds is UV, not infrared. Heat-seeking missiles, yes, infrared is connected with heat. Night vision, yes. So for the second one, it is B, which is detecting. Just now you write only B. In the exam, you have to write detecting fake currency and diamonds. Full form you have to write. Okay, let us come to the third one. Many of you have a little confusion for this. Remember that if the lens is producing inverted, that is real image. Remember, if the object is at 2f, the image will be at 2f, correct? Yes, ma'am. The object is at infinity, the image is here. Now, when the object is between this and this, so the object should be here beyond 2f to get the image between f2 and 2f2. Some of you will say we still don't understand. Remember, object at infinity, image will be here. Then when you bring closer the object, the image moves further. Understanding?
Yes, ma'am.
When it is at 2f, the image will be 2f, which means the image is not at 2f yet, it is before that. So the object is before 2f. Did you understand this?
Yes, ma'am.
So where is it? Beyond
Beyond
2f1.
Beyond 2F1.
Beyond 2f1, where is it?
Option D.
Beyond 2f1. Yes, option D. So what is the third one? It is option D, beyond 2f1. Let us come to endoscope. Uses optical fiber to transmit high resolution images of internal organs without loss of information. Loss of information because 100% reflection takes place, no total internal reflection. The phenomenon is total internal reflection, correct?
Yes, ma'am.
Then we come to the fifth one. Radioactive element is placed in an evacuated chamber. The rate of radioactive this thing will decrease. Evacuated chamber. Uh, Evacuated chamber means there is no obstruction to the particle movements. The rate of radioactive decay will remain the same, but at the receiving, let us say, photographic plate, there will be a little this thing, but the rate is not going to change. No? What is the rate of radioactive decay? It will depend upon the nucleus, right? It is not dependent upon the evacuated chamber. Understanding?
Yes, ma'am.
So it will be C remains the same. We come to the sixth one. 4000 calories heat energy supplied to crushed ice at 0 degrees such that it completely melts to form water at 0. So I will show the working step here. Ice at 0 degrees C completely becomes water at 0
0
degrees.
degrees C.
So this will be Q equal to mLF, and this 4000 calories is equal to mLF is the mass given. If the specific latent heat of fusion is 80,
We have to find the mass.
so m will be equal to 4000 upon 80. So that will give us 50 gram because it is calorie per gram. Okay. What is the mass of ice? D. 50 gram. Amplitude of sound wave is increased from, means it is doubled. The loudness, remember, your L is proportional to amplitude square.
A square.
So L1 upon L2 will be equal to A1 square upon A2 square. Show that. So amplitude initially A1 is A, it is 1, so it will become 2A. I'm just writing 2A whole square. Should I write like that? No. Let us write 1 square and 2 square. Okay? So it will become 1:4. Never mind this. So loudness is going to become 4 times.
Option D, increase
4 times.
Assertion: ice cream at 0 degree C feels colder than water is correct. This is true because it is going to extract the specific latent heat of fusion from the mouth, correct? What is the reason? It absorbs additional 336, yes, due to high specific latent heat, correct?
Yes.
Both of them are true and this is a correct explanation. So it is option A. Two unequal resistances are connected in parallel by a student. Which of the following is true? Now, if they are, thinking step, okay? Let us say this is R1 and this is R2. And let us say R1 is greater than R2. So in this branch there will be I1 as the current and this one will be I2 as the current. Now remember, your I is inversely proportional to the resistance. Less resistance, more current, more resistance, less current. So if R1 is greater, I1 will be less than I2. Agreeable to you? So the current in both is the same is not correct. Voltage of the lower in the voltage is lower. Both of them have the two endpoints, the same endpoints. So the voltage will be the same. So this also is not the correct one. Current in the lower, no, current is lower in the higher resistance is correct. Voltage is the same
across both.
Yes. Now 3 and 4
So
are correct.
option A, 3 and 4.
3 and 4.
So A is 3 and 4. It's good practice for us, right?
Yes.
Man having a box on his head climbs up a slope. Another man, identical box, same distance on the level road. Choose the correct statements. Now one guy is going this way and the other one is going this way. Now level road, when they talk about level road, if they say work done against gravity, then remember theta is to be taken as 90 degrees and work will be 0. So both will do same work against the force of gravity as the displacement is equal. Against the force of gravity, this fellow will do 0, right? Will it be the same work then? This one is climbing up, so he'll acquire this much height. Correct?
Yes, ma'am.
And if he is talking about this, so this one is not the correct one. First man does more work than the second man against the force of gravity is correct. Correct? Because second man is doing 0 work, no, against force of gravity.
Yes.
Work done by the second man due to the force of friction is 0. Not due to force of friction. Against the force of gravity is 0. So, understanding. Second man does more work than the first man. No, he's doing 0. Understood which one is the correct option now? This can be a little confusing. If you find this confusing, just review that concept well, okay? Ninth one. An element decays to this after emitting 2 alpha particles and 1 beta particle. Find the atomic number and mass number of element S. So it is SAZ, no? So how are we going to do this? Your S, A and Z. It is going to emit first alpha, means it is going to become S1. This will be A minus 4 and here it will be Z minus 2. Then again there will be alpha particle. So it will become S2 and A minus 4 means minus 8 and this will be Z minus 2 means Z minus 4 and it's going to become R after emitting beta particle. So A minus 8 will remain the same and Z minus 4 plus 1 means Z plus 1. But this is equal to R 2, 2, 2 and 85. Okay, so A minus 8 equal to 2, 2, 2. A is equal to 230. And sorry, this should be
3, right?
Minus 3, correct.
3.
Yeah, sorry. I don't know, I was thinking of something. Thank you. So S minus 3 is equal to 85. So this will be equal to plus 3 means 88. So 230 and 88. 230, 230, 88.
Option C.
Option C. Understood how this is to be done?
Yes.
You have to give yourself marks also depending upon whether you'd be able to do on your own. If I have been instrumental in giving you that mark, then you have to give yourself 0. Okay, in a 3-pin plug, the live wire, what did I say? Live on the left in the plug, right?
Yes.
So it is thinner. Will it be thicker? It will be thinner to the left and thinner to the right. Thicker, no, thicker, no. So which option it will be?
Option A.
All right. The ray of path is incident on a rectangular glass slab. The path is plotted through the slab. Which ray is not possible? Which path is not possible? Now this is incident ray. This is possible, correct? This is possible.
Yes.
What
Yes,
is
ma'am.
this now? This is turning towards the normal and gets reflected here, and this becomes more than critical angle. Then it should go away this side, no?
Yes, ma'am.
It's turning this side, so this part is not correct. Let us say this one.
It is going undeviated.
It is going undeviated. Are you sure? I am not very clear about it. Is it going undeviated? It's going undeviated. They are saying which one is not possible. I'm having this also not possible. How can it go undeviated here? Huh? Can it go undeviated like this?
No.
Not possible. Let us see this. This is turning towards, and this angle has become more than critical angle. So TIR. So this is possible. This also TIR. 1 minute. If this goes this way, this equal to this, and this one is more. This one is not possible. Even this one is not possible, no? See here, it is going this way, no? It is going into the rarer medium, right?
Yes, ma'am.
So when it is going in the rarer medium, this should go this way. They have shown it turning towards the normal. That means this is denser medium. But can you see over here, it has turned towards the normal, means this is denser and this is rarer. So examiners made a mistake. Okay, it will be C, because you cannot have undeviated going like this. It had to turn this way. Correct or no? It has to turn towards the normal here. It cannot go undeviated. Determine the equivalent resistance of the two resistors which are connected in series. So this is what we have to find. A student arranged the circuit components as shown in the diagram, but he did not succeed to achieve the objective. What has he done?
The ammeter should be towards the positive.
What is the mistake?
Ammeter is connected.
This is ammeter should be here like this. Terminals of the ammeter are wrongly. What is the mistake committed by him in setting up the circuit? Position of the ammeter is incorrect. Terminals are wrongly connected, not this one. Position of voltmeter is incorrect. No, he is looking at this. Terminals of voltmeter are positive to positive. So it is the B thing. It is terminals are wrongly connected. Understood. The positive should have been here and negative should be here. Whether the ammeter is here or here doesn't matter. Positive should be connected to positive. So this should be positive connected to this positive. Made sense?
Yes.
Yes.
Assertion. During the march past, we hear the bass drum distinctly from a distance compared to the side drum. Why? Because the bass drum will have larger surface area, right?
Yes, ma'am.
Produces baser note compared to the side drum. Bass drum. It's not because of the. I mean, it does produce bass note, and the side drum goes pitch a little higher. Assertion is correct. The reason is also correct, but
It's not the correct
Not
explanation.
correct explanation.
but this is not the correct explanation because it is the larger surface is set into vibration for the bass drum. So it is B. So out of 15, how much did you get? Just quickly count and write the marks, okay? Let us look at our next one, which is MCQ. There are, fill in the blanks. The critical angle of glass air is 45 for yellow color. The critical angle of green will be. Now here you will not get directly the answer unless you just write this way. This is 4000, this is 8000. So lambda is increasing. So angle of no, critical angle they said no. So mu is decreasing. So mu decreases and mu and critical angle they are inversely. That means critical angle increases. Now they are telling you that for yellow it is 45 degrees. So for orange and red it will be less than 45, but for green it will be
More than
greater than 45 degrees because this way critical angle is decreasing.
Now it's increasing that.
What is increasing?
45, right?
Critical angle is increasing.
Critical angle is increasing. What
So
did
that-
I write over here? This is 45 green. So red and orange will be more than 45. This should be less than 45, correct?
Yes.
Yes.
Less than 45. So it will be less than 45. So A will be less than 45 degrees for green. We come to B. 27 Mg12 emits beta particle and gets transformed in Y. So your Mg2712 will become Y, which is 13 here and 27 here, correct? It will have the same mass number, means it won't be isotope, it will be isobar, correct?
Yes, ma'am.
So what is it? Isobar. Isobars will be the nuclei. They are the elements, they are different elements which have the same mass number. What are isotones? Isotones have the same number of neutrons. Okay, two elements with same number of neutrons. Understanding? The region of spectrum which does not excite retina and therefore not visible is called as,
Invisible spectrum.
this is common sense, no? This is not physics. The substance ABC has the lowest SHC if heat supplied to all of them is the same. Normally when we look at this, we think of Ohm's law, correct or no? This type of graph. But what are they telling you? The temperature, this is the temperature and this is the time. So now let us do this. Show the quick diagram so that you'll be able to understand. So this will be time for C and this will be time for A. Agreeable to you?
Yes.
The heat is supplied at the same rate. So for the same temperature, C is taking longest. That means its SHC should be less. For same temperature, C takes longest. So you compare it with water, which takes longer to get hotter, no? Therefore, SHC of C is max. Okay, and SHC of A is minimum. There is another way of doing this. If you take this way vertical line, okay, then what do you see over here? The slope of A is more, so this will be sharp rise in temperature. Did you understand? In the same time. So for the second type of thinking, right over there, or show this and say for the same time interval, A shows sharp rise in temperature. So when will any substance get heated faster?
Low SHC.
Therefore, A has min SHC and C has max SHC. Is it making sense to you?
Yes, ma'am.
Lowest SHC किसको मिला आपने? A, ना? Low resistance is the characteristic of
Low melting point.
correct. This was easy. Right over there. Now which one you would have got the marks on your own, you have to give. If you don't get marks, you have to give yourself 0. In a block and tackle system, increase in weight of the movable block is going to reduce my efficiency because the weight of the movable block will get added to the load, the useful load, correct?
Yes, ma'am.
So what will happen to the efficiency? It will decrease. Understanding?
Yes, ma'am.
This was also okay. Then we come to the second part. So out of 6 marks over here, check how many you will get from A up to F. Write in the margin, count and write the marks. Count and write the marks unless it's 0. You don't write means you get 0. The force is applied on a body capable of rotation about an axis. Yet no rotation occurs. When will no rotation happen? When it's pivoted, no, rotating about the axis. The force must be acting at the pivot, no? What is turning effect? Right over there, turning effect is force multiplied by perpendicular distance, correct? You know the whole phrase, what do
Yes,
we say?
ma'am.
Perpendicular
The
distance of the
the
line of action of force from the axis of rotation, correct?
Yes, ma'am.
Now either the force should be 0 or the perpendicular distance should be 0, correct?
Yes.
Why? Because there's no rotation. Okay, equal to 0 right over there if no rotation. No rotation means what? No turning effect. Understanding? Therefore, what does it mean? F equal to 0 or perpendicular distance equal to 0. Understanding?
Yes,
This is your still thinking step. Understanding? Okay, but they are saying that the force is applied. So this is not applicable because the force is applied. So the perpendicular distance is 0 means what? The force is applied at the pivot. Understanding?
Yes, ma'am.
Yes, ma'am.
Okay, so after all this that should happen in your brain, we can write from here turning effect is 0. Therefore, the force, if applied where?
At the pivot.
At the pivot.
At the pivot or the fixed point. Pivot is, if force is applied at the pivot, then perpendicular distance equal to 0. Therefore, turning effect equal to 0. Therefore, no rotation. We'll just write it in short. Is that fine?
Mm-hmm.
Yes, ma'am.
You are provided with printed piece of paper. Using this paper, differentiate between this. What do? You hold it close to each lens. So within focal length, if the print is there, with concave I will say diminished, but convex I'll say magnified, and both will be virtual images, correct? So how will you word this? Place the printed paper very close to each lens. Then in the next line, put one bullet and say if upright, comma, magnified print, comma, then which lens it will be? Underline convex lens.
Convex lens.
Okay, underline upright and magnified. The next bullet, what you'll say? If, put diploma upright and diminished,
Diminished.
and put print dots. ditto marks, then ditto marks, and here you will say,
Concave lens.
yeah, concave lens. Okay, so we finish with question number 2. This was 10 marks. Do you think you will get full marks? Just count and write the marks quickly. Question number 2. We finished all of them. See there, we had 6 and these are 4. Maybe for this you needed my help. Okay, but this maybe you knew how to do. So give yourself marks. Write marks out of 10. So you can total up the marks and then you'll come to know in which area you have to work. Set of Christmas tree lights are made from 20 identical lamps connected in series. Each lamp is designed to take a current of 0.25 ampere, and the set plugs directly into 230 volt mains electricity supply. So what do we see? Voltage is given as, this is your question number 3, first part, right?
Yes, ma'am.
Voltage is 230 volt and the current in each lamp, I in each lamp is equal to 0.25 ampere. Now remember, keep this in mind that these are all bulbs like this, and each one is having, the path will be the same, right? That means current in the entire circuit will be this only. Understanding?
Yes, ma'am.
So this means I in circuit, put into bracket and say I in circuit is how much? 0.25 ampere. We are writing the statements properly, right?
Yes.
Now total resistance. So we have V is equal to IR by Ohm's law. Remember now, every mark counts. We don't want to take any chance. We want to write the reasons whenever possible. So R will be equal to, take I that side, so V upon I. How much is V? 230. How much is I? I'll write 25 here and I'll put 100 here. And I want to avoid using decimal numbers. Okay, so you have 4 here. How much is that? 4 3 is 12, 1 4 3 is
920.
920 ohms. And what you'll say, this is the resistance of set of lights. So this becomes your answer A. Now they say calculate the resistance of one of the lamps. So resistance of how many lamps are there? 20.
20 lamps.
Resistance of 20 lamps is equal to 920 ohms. Therefore, resistance of each lamp, write it fast and neatly, okay, will be equal to 920 upon 20. Agreeable to you?
Yes.
46 ohm. Alright, so this is your answer B. This was for 2 mark, 1 mark for this and 1 mark for this. The second part, the difference between the temperature of water at the bottom and top of the waterfall is this. Calculate the height of the waterfall. So what are they telling you? That delta T in the temperature is 0.2 degrees C. And they say find the height of the waterfall. Height of waterfall. So remember, when the water is falling, when it strikes the surface of the earth, maybe it is the rocky part or whatever, There's going to be force of friction, there's going to be conversion into kinetic energy because definitely temperature is changing. When the temperature is changing, your potential energy is converted into kinetic energy. That should be your assumption. Understanding? So what are we going to say? That final heat energy equal to kinetic energy, which is equal to initial potential energy. Do you agree with that?
Yes.
And here what you'll say by law of conservation of energy. Just write that, I don't have space. In the next step, what you'll say, therefore, heat energy means mc delta T is equal to mgh, correct? So if you take the unit mass or whatever mass, the mass remains the same. And acidity of water is 4200 multiplied by delta T is 0.2, so 2 upon 10 is equal to G is given as 10 and they're asking H how much. So 0 and 0 got cancelled and I have 840 upon 10 is equal to H. So therefore height of waterfall is equal to, how is it, good, bad or ugly?
Good.
Would you get 2 marks or would you get confused in the beginning? If you would get confused, just give yourself happily 0, because now when you give yourself 0, it will be remembered by your brain. Why is the work done by the fielder when he takes the catch in the cricket match is negative? Now they're already telling you that the work done is negative, means theta must be 180 degrees. If 180 degrees means the two forces are going to be in opposite direction, correct? And the displacement, the force and the displacement, correct? So how are you going to word it? That when fielder catches takes a catch, catches the catch, I can't say no. Fielder takes a catch, comma, he applies, now don't say ma'am, she applies, because women's team Zindabad, right? They got the World Cup, no?
Yes.
Yeah. So he applies force in direction opposite to, in the direction opposite to the direction of displacement into bracket velocity of the ball. You understanding?
Yes, ma'am.
That is theta is equal to 180 degrees. You wrote this much?
Yes.
Then in the next line you will say W equal to Fs cos theta equal to Fs cos 180 degrees equal to Fs into minus 1 equal to minus Fs. Hence, the work done is negative. How is it, good, bad, or ugly?
Good.
Good, ma'am.
Fourth one. Certain amount of heat Q will warm 1 gram of material X by 3 degrees C and 1 gram of material Y by 4 degrees. Which one has high SHC? Giving reason. What will you say? Which is showing sharp rise in temperature?
Why?
Why?
Correct. So Y will have higher or lower?
Less.
Huh. So high, they are saying which material has high specific heat capacity. So it will be X. Okay, for the same heat, it has shown slow rise in temperature. Understanding?
Yes, ma'am.
Yes, ma'am.
Do you want to do it mathematically? If you do that, then Q of X will be equal to Q of Y. That means MC delta T of X will be equal to MC delta T of Y. See, what I told you initially also makes sense, but some of you may get a little confused there. Now, isn't mass the same 1 gram, 1 gram?
Yes, ma'am.
Okay, so below this, now I will say C of X upon C of Y will be equal to what is on this side, delta T of Y upon delta T of X. Now delta T of Y is 4 and delta T of X is 3. Okay, so therefore SHC of X will be greater than SHC of Y. I think writing this way, you will get better understanding from the examiner and you will also understand it better.
Yes, ma'am.
Yeah, no? Correct?
Yes.
So give
Ma'am?
yourself.
Ma'am, after that, should we also add that because it has sharp rise in temperature, or should we
No,
just
sharp
leave it?
rise in temperature, no, slow rise in temperature because they said higher
Yes, ma'am,
SHC.
sorry.
So it will be slow rise in temperature, we'll have to mention. You can mention. Yeah,
Yes.
I think ideally it should be mentioned. Opera singer states that she can crack the glass by singing, by using just her voice, assuming she saying the truth. Why do you think it is possible? So here what will we write? If the frequency of opera singer's voice into bracket external periodic force equals, double underline the word equals, the natural frequency of glass, then due to resonance, underline the word resonance, the glass will vibrate with larger amplitude, comma, thus cracking. Underline larger amplitude. underline external periodic force. So these are the keywords which the examiner wants to look for: resonance, the frequency is equal, and then larger amplitude. I think I have made shorts or something like that with the person who's singing very high note and cracks the wine glass. I think it's a short that I made. Let us look at this. You can have a look at it, okay? A construction worker wants to paint the danger signal near the construction site. He tends to use blue paint. Isn't he being silly? What change would you suggest to him?
To use red paint.
He should use
Red paint.
Put red in capital, paint, as it has the longest wavelength, correct?
Yes, ma'am.
Longest wavelength and gets least scattered, correct?
Yes, ma'am.
Least scattered. What do we write into bracket, underline least scattered? What you'll say? Intensity of scattering is inversely proportional to two-fourth power of wavelength. That is I proportional to 1 upon lambda to the power 4. Thus it can be seen from far, and the danger can be prevented, correct?
Yes, ma'am.
Okay, do not use any fancy word. Don't say danger can be minimized, just say prevented, because you are able to see from far and you'll take adequate precaution to avoid the danger. Which of the two wires of similar dimensions, constantan, nichrome, would you use for electric heater element? Now for the heater, my main job is to get heating effect. So I should use something that will have its resistivity increasing with temperature. Now constantan has resistivity remains unchanged, right? And
Yes.
nichrome, the resistivity increases with increase in temperature, correct? Come on, if you've forgotten, open that page. Tell me which page. Somebody else will look at the book, somebody else's hands will turn the pages, somebody else's brain will become superior.
And Constantin and Magnet, those two are
Constantin and
Magnet.
what happens
Page
to them?
196.
So they remain constantly increasing temperature because they are
Okay, so you know that, right?
Yes.
What page it is on?
196.
196. Did you find it? Show her. Yeah, okay. So what you'll say, for constantan, comma, resistivity remains unchanged, correct? Unchanged with
No change in temperature.
increase in temperature. See, heater means main thing is that the temperature is going to increase, but the resistivity will remain unchanged. Okay, but for nichrome, what is happening? Tell me. The resistivity increases. See, it's written over there. Where's the page gone? You close the page also. Overconfidence, that is, baby. Resistivity increases with
Increase in temperature.
Increase in temperature. Correct? Which helps in producing greater heating effect. Agreed?
Yes, ma'am.
Greater heating effect, and hence they say, what would you use? Hence I would use. Don't say you would use. Don't tell the examiner to use it. Okay, examiner saying what would you use means I would use use it for heater. Double underline nichrome. Resistivity increases with increase in temperature. That finishes section.
Ma'am, what other
A.
material?
What other material is best? What is the other material? Okay, so the other material is constantan. What is constantan? Constant. What did I write? Constantan is best used for
resistance wires.
Resistance wire. Resistance wire in which the value of resistance must not change. Needs to remain constant. Needs to remain constant. How is it? Good, bad, or ugly?
Good, ma'am.
So justify will be for 2 marks, and for this will be 1 mark, constant. Okay, so that finishes our section A, 40 marks. Count your marks and tell me how much you're getting. We stop there for section A. Now we start with section B, and from section B we have to solve any 4 questions. Let us look at question number 4, first part. A boy took an earthen pot which was filled with water up to its brim. The earthen pot was conical in shape and kept with its apex in downward direction. So we have the inverted cone is like this. This is how it is. If the vertical height of the earthen pot is from here to here, this is 24 centimeter. Where does the center of gravity lie is the first question. So question number 4, the first part A, you have shown the diagram somewhere on the page. So you will say for solid cone. And what you'll say, center of gravity equal to where? H upon 4 from base, which will be 824 upon 4 from base, that is 6 centimeter from the base. So if I show the radius this way and this way, this will be from here to here 6 centimeter. Okay, this will be your CG for case 1. Now the boy pours out all the water from the pot. how will the center of gravity shift towards the open end or towards the apex? So below this we will write B, and what you will write is for hollow cone. For the hollow cone, we will say CG will be equal to h upon 3 from the base. So that will be equal to 24 upon 3, put ditto mark like that, which is equal to, thank you, 8 centimeter from the base. So this will be, now the second position will be from here to here. This is your center of gravity, 8 centimeter. This is your second one, and this was your first one. So it has turned towards the apex. Can you see that? What did they ask you? That how will the center of gravity shift? So you will say, therefore center of gravity shifts towards the apex
by 2 centimeters.
Very good. By 2 centimeters. Okay, so this becomes your answer B. Now the C part, the boy wanted to grow a plant, so he filled it completely again. So now this is your B part. Now C part I don't have space, so I'm just writing here. What you will write over there, he fills completely. So what will be the new position of the center of gravity? It will be solid cone again, correct?
Yes,
Solid cone, and therefore center of gravity is 6 centimeter from base. Okay. So now it will move towards the, if they ask you where it will shift towards the base by 2 centimeters. Okay. We come to the next one. This was again diagram based question. We have a hammer throw is an athletic event. The athlete throws the heavy metal ball attached to a wire, by a wire to the handle. So there's the handle here, this is the wire. The hammer thrower swings the hammer round in a circle before letting it go. So he swings the hammer slowly first and then faster. Figure 2 shows the overhead view. So this is the hammer thrower, these are his legs, these are his hands, this is the handle, and this part is here, and this is the hammer. Okay. In which direction A, B or C or D does the centripetal force act on the hammer? So we will say for A, centripetal force. In which direction? In direction of B. Into bracket, since radially inwards. Remember, not just that, but you should be able to answer the questions based on this. We come to the B part. For the B part, in which, what is the cause of the centripetal force on the hammer? It will be the tension in the wire. And the C part, the instant is shown, at an instant showed, the athlete lets go in which direction. So at this instant when he lets go, anti-clockwise. So remember, this from here to here will be the radius, okay, of the circle, like this. Understanding?
Yes, ma'am.
So at this point along the tangent, if the motion is this way, it's going to go this way, not towards A. Okay, so keep visualizing this, and then you will say that hammer
Moves towards C.
moves towards C. In which direction? Moves along direction of C. Okay. So this was your second part, and we come to the third part. Third part, pulley system. What are they telling you? Now this is a very familiar scene. Velocity ratio is equal to 4, which is equal to number of pulleys, correct?
Yes, ma'am.
Lift the load of 175 kgf. So L is 175 kgf. Through a vertical height means displacement of load is 15 meter. The effort required, so E is equal to 50 kgf in downward direction. Now remember, the effort is in downward direction, which means velocity ratio equal to the number of pulleys. Sometimes they will use, now this is just in case your teacher is asking you some application question. Okay, let us say this is the load. Now when you draw the load, the hook should be here like this, and when you show the load from the center of gravity, you have to show it going downwards and say that it is load. If they ask you for diagram, don't just write L and E. Now if it is vertically upward effort, then what is going to happen? Sorry. I want to put one more pulley here, okay? If it is vertically upwards, then this will go this way, then this way. Sorry, I can't show the tension. Can you see that?
Yes, ma'am.
Okay, so in case if this is the effort vertically upwards, can you see 1, 1, 2, 3, 4 and 5? This load is supported over 5 tensions and effort is 1 tension. Can you see that?
Yes, ma'am.
So if the effort is in a vertically upward direction, then 4 pulleys and 5 is the mechanical advantage. What is mechanical advantage? Load upon effort means 5T upon T. That will be equal to 5, correct or no? MA will be equal to 5. So remember that if the effort is vertically downwards, can you see that? Effort is in downward direction means velocity ratio and the number of pulleys are the same. If they say vertically upwards, then the mechanical advantage velocity ratio is not equal to the number of pulleys. Your mechanical advantage will be 5, velocity ratio also will be 5, and the mechanical advantage 5 will not be equal to the number of pulleys. Understood?
Yes.
This is true only when the effort is in downward direction. Understanding?
Yes.
Okay. So now that you understood this much, this is the first part. What is the first part? Say distance moved by the effort. So distance means displacement of effort is connected with velocity ratio. What is the formula for velocity ratio? dE upon dL, correct? E comes before L in the alphabet, like that you have to remember. So 4 is equal to dE upon dL is 15 meter. So dE is equal to how much? 60. 15 into 4 means 60 meter. Are you with me so far?
Yes, ma'am.
So this is your answer 1. Then we come to the second part. They are saying work done by the effort, which means it will be effort into displacement of effort. Can you see over here? The work means your work will be in joules, so effort must be in Newton. So can I write 50 kgf? No. What will I have to do? I will write this as 150 kgf multiplied by 10, correct? M into G, because mass of the effort will be 50 kg. Is it 50?
Yes.
Why did I write 150? Why did I see 150? And you all didn't say anything. I don't know what I saw. So this will be 50 kgf multiplied by 10, which will be equal to 500
Ma'am, into 60.
into 60. 50 into 10, that is the effort, Newton, multiplied by 60 meter. Okay, so equal to below equal to, and this will be 5 6s 30, and how many zeros? 1 2
Three.
3. So 1 2 3, so 30,000 joules. Okay, that is your answer 2. They are saying mechanical advantage. A mechanical advantage is load upon effort. The values have been given: 175 kgf upon what? 50 kgf. Kgf got cancelled. 25 twos is okay. 25 twos and 25 7 times. So we are getting 3.5. Can you see that? This is the efficiency is going to be definitely less. Let us see. They read my mind. See the efficiency. Efficiency will be what? MA upon VR multiplied by 100%. What is MA? 3.5. But when you are writing this, you could write it as
7 upon 2.
7 upon 2, and in the denominator VR is 4. Understanding how we can go ahead with that, and 4 goes here 25 times. 25 sevens is 175 upon 2, which is 87.5%. Are you getting that? 87.5% also? Okay.
Yes.
Let us move to the next question, and let's be quick. Question number 5. Now question number 5, you will have to show these diagrams. Show these diagrams and tell me when you are done. Don't draw very big diagrams. Tell me when you are done.
Done, ma'am.
Okay, good. Two students are conducting experiments with identical 100-gram mass simple pendulums, each raising the bob 5 meter above the mean position, and the graph depicts the relationship between the distance from the mean position and the velocities. Demonstrate by using mathematical calculations that the path followed by student 1 is devoid of friction. Now let us look at both of them are raising 5 meters above the mean position. So H is 5 and for student 1,
We'll have to prove that all positions that the kinetic energy and potential energy remains the same.
yeah, that is true, but I have to I have to check potential energy at extreme, no?
Yes, ma'am.
At extreme position will be equal to mgh, correct? Now mass of the bob
100 grams.
100, but remember potential energy means joules, so 100 should be converted into kg. They have told to take g as 10. meter per second square, and the height is 5 meter. So 1, 2, 3 zeros are gone, and we have how much? 5 joules, correct? 5 joules we got? Okay.
Ma'am, but if this is P at extreme position, then the height at extreme position would be 0, right?
Height at extreme position, this is velocity. You are looking at velocity 0, is not height 0. This is velocity. The velocity here is 0. Now I am taking the data from here. I'm not looking at the graph.
Okay.
Okay?
Yes, ma'am.
Now let us come to the kinetic energy at mean position. Is going to be equal to what? Half
Half
mv
mv
square.
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 That will be half into 100 upon 1000 multiplied by velocity is 10 into 10. 1, 2, 3, 4. What did I do? This is 100, no?
Yes, ma'am.
Oh, I cancelled one more 0. 3 zeros are gone. And 10 upon 2 means 5 joules.
5 joules.
Correct? Then what you will say, since PE at extreme equal to KE at mean equal to 5 joules, correct? Now below this I don't have space, but I'll write here. Therefore what are they telling you? That it is devoid, no?
Friction.
Therefore path of pendulum is devoid or without friction, because there is no loss of energy. In case you are not able to understand this, write over there, since no loss of energy. Agreeable to you?
Yes, ma'am.
Now your B part will again have the potential energy at extreme position is going to be equal to mgh, because both of them are going to 5 meter. So it is going to be 5 joule as you have seen it in the earlier part. Okay? But the kinetic energy at mean position will be equal to half mv square, which will be half into 100 upon
1000
multiplied by 8
8
into 8. So 1 and 2 zeros got cancelled, and 2 ones and 2 fours. So I am having 32 upon 10 means 3.2 joules. Okay? Does it exhibit the breach of law of conservation of energy? Does it mean that potential energy is not equal to kinetic energy, so it has violated the law of conservation of energy? No. What must have happened? There is some energy which is lost in overcoming the friction. So you will say here that potential energy is not equal to kinetic energy. In fact, what you will say, that kinetic energy is less than potential energy, as the energy is is used to overcome the force of friction from the surrounding, correct? From the surrounding medium. Okay, so you will say therefore there is no breach of law of conservation of energy. Energy got dissipated, no?
Yes, ma'am.
So since degradation of energy. Made you all think, no, this question?
Yes.
It's not difficult, but it is little bit different type. Now, please draw this triangle and let me just tell you how the diagrams of this should be drawn. You will show the ray coming perpendicular to this surface. Show it perpendicular. They have not shown it perpendicular, you show it perpendicular. Okay, if it is entering at right angles, it will go undeviated. The arrow must be seen everywhere. Now you will show this, the normal. If this is 48, show this angle as 42 degrees. So this angle becomes 48 degrees. Now write on wherever there is space here, write critical angle is equal to 42 degrees, they have mentioned. And then you will say at surface AB, angle I equal to how much? 48 degrees, which is greater than 42 degrees. Therefore, total internal reflection. So it will go 48. This will be 48 degrees. So this will be 42 degrees. This is 90. So this will be 48 degrees. And show the arrow. Now you will show the vertical line here to show the normal. And here this will be 42 degrees. Then what you'll write over here is at surface angle I is equal to 42 degrees, which is equal to critical angle. Can you see that? So it will go along like this, and this R will be equal to 90 degrees. Therefore, you will say it goes along the boundary, no, of surfaces, and angle of refraction becomes 90 degrees. Understanding? Now it is for 3 marks. So make sure that you supply with enough information so that you don't lose those marks. Understood?
Yes, ma'am.
Now they say redraw the diagram, complete the part till it emerges. Also calculate the net angle of deviation of ray PQ when it emerges from the prism. So this is your first part. Okay. The second part, they are saying net angle of deviation. which means the angle between the original incident ray and what? Final
Emergent ray.
emergent ray. So you will get this way. This is, now I'll use another color so that you don't get confused. This ray will go, original path of this ray would be this way, correct? This is the path of the original ray, and this is the final ray, so I will produce this backwards, understanding?
Yes, ma'am.
And this ray has turned like this. Did you see that? No? Not understanding? It should have gone like this.
Yes.
But it has turned ting 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 ting. Can you see? It has gone like that. This is not the angle. This is not the angle of deviation. Because the ray should have gone this way. But now it is going to, if you keep a pencil or pen along that and rotate it like that, you will see, you will get an obtuse angle. If you rotate it, you will not get this angle. Understanding? Okay. So what is this? Tell me, how much is this angle?
$42.
This is 42, this one?
48.
This will be 48 degrees. Okay, this is 90, yes?
Yes, ma'am.
Okay. Can you see this and this vertically opposite? Dekha kya?
Yes, ma'am.
So how much is this?
42.
22.
This angle, this one. This is 42 degrees. So this will be 48. This is 90, correct? How much is this?
132.
So it will be 180 degrees. You found the
Ma'am,
same.
but this angle is 48, so this should be 48, right?
That is 42.
Now tell me, how much is this angle?
Oh. Okay, 40.
This is 48, no?
Hmm.
So this is 42, right?
Okay.
And I wrote also over here. Can you see this? I wrote also over here 42, and yet you say it's 48.
Sorry, ma'am.
What did you draw? Pathetically small diagram. That is what. So how much is that? Tell me. 132 degrees. Bacha, you found this diagram from this paper only?
Ma'am, this was in an online, like, I found it online, ma'am.
Is it? Okay.
Yes, ma'am.
Now this again, we get a diagram. The boy uses blue colored light to find refractive index of glass. He then repeats the experiment using red colored light. Will the refractive index be the same or different in two cases? Now refractive index, he is finding refractive index of the glass, right? Okay, didn't understand. For red color. Red color. What will you say for red color? Lambda is equal to
8,000 angstrom.
8,000 angstrom unit, correct?
Yes.
Now, if you say that lambda is more, so refractive index of lambda will be
Less.
less. Okay, correct or no?
Yes.
Yes, ma'am.
But the thing is that when I take the glass prism, okay, or let us say I'm taking the glass slab, don't I write over here it is a monochromatic ray of light?
Yes, ma'am.
So sine I and this sine R, I have to take ratio of this and this. So when I take sine I and sine R, I'm using, he is finding the refractive index of glass. So will glass change? He has to use monochromatic ray of light. So he uses blue, then he uses red. ठीक है, whatever it is, but the angle will be it will go refracted through the same angle because the glass prism glass slab is the same. You are understanding this?
Yes.
Yes.
Okay. So what you will say is, so you have written what you're trying to do. So this is your third part, and you'll say for uh, blue color, refractive index of glass will be the same as for red light, and since glass slab is the same, its refractive index also will be the same for different colored lights. Okay, since the glass slab is the same. Otherwise, the glass slab will have different refractive indices, no?
Yes.
Now, they didn't say that you have to take red color only, then it will be 1.5. Hai na? The candle of size blah is placed so many meters from the eye lens. What is eye lens? Convex or concave? Eye lens is convex lens. Now, if you are confused, remember you are able to see because the image has fallen on the retina, no?
Yes.
That means it has fallen on the screen, which means it's a real image. Real image means can't be concave. Understanding?
Yes.
So,
Yes.
So height of object equal to 2 centimeter and it will be positive, correct? Then object distance is 0.25, but it will be minus and right over there since in front of lens. Image is formed on the retina. So V is going to be
0.25 meters.
Meters. I didn't write, no? Retina, this is how much? 25 millimeter, and it will be positive and right over there since behind lens. For the focal length, we will have to make this meter into centimeter. So that is 25 centimeter, which is equal to minus 25 and minus 250 millimeter. Agreed?
Yes. Mums.
What? What?
We have to convert everything into centimeters or millimeters.
whatever we do, it has to be the same. And I don't want any decimal, so I am taking millimeter. Later on, last question, last answer, we can convert into centimeter. Okay. So focal length equal to question mark. How many of you have forgotten the formula? 1 upon f is equal to 1 upon v minus 1 upon u. I saw so many of you getting confused. 1 upon v will be 1 upon plus 25. Okay, minus 1 upon, this is minus 250. So that is equal to, I'll take 250 as the LCM, and 25 goes 10 times, and here I will take, oh, this minus minus will become plus, no? Plus, and it will become ones. Agreeable to you?
Yes, ma'am.
So that is 11 upon 250. So therefore F is equal to 250 upon 11 millimeters. How much is that? 11 2's 22, remain 3. So 11 2's 22, remain 8. 7 77 3, then 12 millimeter, which is equal to 2.27 centimeter, and it is positive, so it is convex lens. All right.
Yes, ma'am.
They told the size of this, they could have asked for magnification. How's it? Good, bad, or ugly?
Good, ma'am.
Thermometer with blackened bulb shows sharp rise in temperature. Identify the rays. They will be infrared. Just I will write IR. Second one, which prism should be used for obtaining? Is it rock salt prism or quartz prism?
Rock salt prism.
Rock salt prism.
Major use of this ray?
Safety devices.
You can't write safety devices. This is a general. You can say it is
TV
used
remote.
in
TV remotes.
TV नहीं लिखना है, television लिखना है. Television remote. This all of you will remember, because remote you always have it in your hand, no? But don't write TV. You are getting one full mark for that, and you write only TV. Write television full form, no, for that one mark. Okay, stretched wire made to vibrate in different modes. If the wavelength of the wave is made, mode A is 1 meter. Wavelength of the wave produced is 1 meter. What is the wavelength of the wave produced? Obviously, this is 1 meter. Why did they mention? So 0.5 means it is half a wave, right?
Yes, ma'am.
So your A, lambda A is equal to 1 meter is equal to 0.5. Correct? This is one full
Yes,
wave,
ma'am.
right? What is the B part saying? In which case
Is the note produced louder?
Louder.
Give a reason for your answer.
louder will be here.
A.
So A is louder since it has
Higher amplitude.
larger amplitude. And
Loudness is directly
Since-
proportional to square
very
of
good.
amplitude.
Loudness is directly proportional to square of amplitude. A louder. What is C? Which case pitch is higher?
B.
B has
Higher pitch.
since has
Higher frequency. And frequency is
no,
directly
that's okay.
proportional.
Yeah. Now this one. You will have to show this diagram quickly.
Done.
Done? Now see here, CG I have shown here. If this is the center, CG is below. If this is the center, CG is the same. If this is the center, if this is the center, CG is above that. Understanding? Arrange the following pendulums. What you will say, the length of X is equal to length of Z. Okay, and length of Y is max, length of W is min, correct? So here I will say therefore frequency of Y will be minimum. Here therefore frequency of W will be equal to max, and here I'll say therefore frequency of X equal to frequency of Z. So you are going to have Y, then you will have Y.
Great. They've asked us to use greater.
No,
than
they are
equal to.
asking in their range according to their natural frequency. So I'll start with smaller means Y. Y will be less than X will be equal to Z, correct? And that will be less than W because it has got a maximum. So this is your A answer. For B answer, if the pendulum Z is initiated into oscillation, the pendulum will exhibit highest amplitude will be the resonant one. That means X. So which one it is? X. Okay, and the C will be, this is so as frequency of X equals frequency,
Natural frequency.
natural frequency, natural equals natural frequency of Z as they have same effective length. Next line, hence when Z is set into, instead of initiated, I'm using the word set into oscillations, X experiences resonant vibrations and exhibits highest amplitude. Okay, there is some more thing has to be written over there. They are saying highest amplitude means it is highest from all, correct?
Yes.
It's not just compared with X and Z. So what you will say, all the others will also start oscillating, but with smaller amplitude, as their frequencies,
The natural frequency.
their frequencies are different. And experience forced vibration. Okay. Now I think this one, Lata stands between two cliffs, claps a hand, determine the time taken by the first echo. This is doable. This is 160 meters, so this will be 10 meters. Only thing is that, determine the time taken by her to hear her first echo. The first echo will be from here, correct?
Yes.
And not because of this. First echo will be not here. Some of you will say this is 10 meter and we'll take the first echo means this.
But the minimum distance for
I know. But the thing is that for the first echo, we tend to think that this is your D1 is less than D2, right?
Yes, ma'am.
So we tend to think this, but 10 meters she will not hear the echo at all. So her first echo will be because of D2. Understood? This was again thinking type of question, because many children will say, first echo will be because of this. Understanding? Okay,
Yes.
so we have done how many? 5, 6, 7? 2 questions?
4,
only?
5,
4, 5, 3 questions we finished, right?
Yes, ma'am.
Okay. So this we'll have to do later. This one, question 7, I don't think we'll be able to handle this just now. Okay, we'll have to stop here. Question number 7 we'll have to do. Okay?
Yes, ma'am.
So we had finished up to question number 6 and we had to start with question number 7. Now in your question number 7, we have the diagram in which we are told that this Lata is standing between the two cliffs and claps her hand, and determine the time taken by her to hear the first echo. Speed of the sound in air is 320 meter per second. Now the first echo is not going to be because of this D1. Your D1 is going to be 10 meter. Okay, so what you will say is that first echo will be due to, show over here from here, D2, which is equal to 160 meter. All right, and the sound of the clap is going to be echoed, so it will be twice this D2 and come back. Okay, so 2D upon T, so you will have T equal to 2D upon V. That will be equal to 2 into 160 upon 320. So that will be 1 second. And this is for 2 marks. You can see that it's an easy question. But supposing they had to ask you, when will the second echo be? Now they are not asking for the second echo. Do you know when will the second echo be heard? What will be the distance for the second echo?
It will be 160 plus 117 plus 10.
It will be, now see, the first sound will go this way, and then it will, this way it will go, and it will come here. Then it will go this way and come back here. You understanding?
160 plus 170 plus 10.
Ha. So your total distance V will be equal
340.
to, you can't write D2. You have to say over there total distance upon time. And what will be the total distance? Distance will be first D2, then it will again come back D2 plus D1, understanding? D1 and then D1. Understanding?
Yes.
Okay, and that upon T. So 320, and then I'll write D2, D2 and then D1, D1 like that. Understanding? Yeah, so that would be the second echo, will be the echo of the echo. First echo will be heard and that it will go this way. Understanding?
Yes.
Yes.
Okay, let us come to B part. A live wire makes an accidental contact with the metal case. So this is the metal case, this is the live wire, and this is the metal case. It's making the contact here. Which circuit A or B in the diagram illustrating an electric iron is considered safe for the user, assuming that fuse is present in the live in both cases? So the person touching this, what does it say? Live wire, the metallic case. And here can you see, this is not the metallic case, that is. So this will be safe? No. Will this be safe? Yes, because metallic wire is connected to the, the earth connection is connected to the metallic case. So how will we word it? Circuit A is safe. Underline A is safe. Underline the keyword. That you will write in the first. Don't write like a bhashan. Okay, I was looking at some of your answers and I see that you all are writing just bhashan. Supply the keywords and you will say this is so as the earth connection is earth wire is connected to the metallic case, hence the current will be conducted to the earth and the user will not get a shock, electric shock. Okay, and then in the second paragraph you could say circuit B has earth wire not, underline not connected to metal case, so it will um, it will make the current flow through the user giving him an electric shock. Okay, the fuse is going to melt, but remember the metallic case will still be connected to live, so it will be on having high potential. Look at your second part. These are all 2 mark questions. Fuse is rated 5 ampere. Can it be used for the geyser which is having these markings? So remember, for the geyser, question number 7, second part, the power is given as 1540 watts and the voltage is 220 volts. So power is equal to VI. You have to know the safe current. So therefore, safe current equal to I will be equal to, take this V that side, so P upon V, which will be 1540 upon 220. Both are divisible by 11. So 11 14 times, 11 2 goes 7 times. So that will be 7 ampere. Now, if it is 5 ampere, can I use 5 ampere? So therefore 5 ampere fuse cannot, underline cannot, be used as the current for the working of geyser is 7 ampere. Okay, and the fuse will melt and not allow the geyser to function. All right, so remember the keywords to underline. We have a circuit diagram, which is the next question. This is for 4 marks. In the diagram, calculate the power consumed in the circuit when switch S1 is closed and switch S2 is open. Can you just quickly show this diagram? Tell me when you're done. Okay, now if S1 is closed, remember it will be this will be shut, so we will have the current going this way, it will go this way. Now this is open, so this will not be part of the circuit. Understanding? So it's better to show the diagram for clarity. This is S1. this is your 60 ohm, this is your 20 ohm, and this will be connected, this will be your 5 volt. Okay, so if you were to shut this, then 60 and 20, they would be in parallel, correct? So you will have 1 upon Rp will be equal to 1 upon 60 plus 1 upon 20. LCM is 60, so 1 and 20 goes 3 times, so 4 on 60, which is 1 upon 15, and we'll say therefore Rp is equal to 15 ohm. Your PD is how much? 5 volt. So the power in the circuit, so power in circuit will be equal to P is connected with V and R means V square upon R. You must remember the power formula. Power is equal to top margin, right? VI equal to I square R, which is equal to V square upon R. You must write this many times so that you do not make mistakes. So V square will be 5 into 5 upon 15. How much is that? 3 ones and 3 sixes, 18. So 1.67 watt. So this would be our answer A. Now they are telling you that if S2 is closed, if S2 is closed and S1 is open, then in that case, what would happen? I will have this as a 20 ohm and it will be this way. This is 60 ohm and then S2 is shut. So I'm not going to show this connection over here. 1 second. My S1 was here, but S1 is now open. So I don't have to show it. I will show here S2 and I'll close this like this and then it will go this way. Now even if there is a wire over here, that wire, it does not matter because the connection will be, so I don't need this in the circuit. The current will go this way, this way, this way, this way. It will not go here, okay? And it will go through S2 and come this way. It will not go this way. It will come here to take the path to complete the circuit. Did you understand what has happened here? In this case, what is happening? 60 ohm and 20 ohm, how are they? They are in
series.
So RS will be equal to 60 plus 20, which is how much? 80 ohm. And then power in circuit will be using the same formula, that will be V square upon R. This is Rp, I'll call this as Rs. So 5 into 5 upon 80. So 5 goes here 16 times, and for 16, oh, I'll have to divide this. I don't have space for rough work. You have the place for rough work? So 16 decimal point and 0, 16 threes, 48 remain 2. So 16 ones, 16 remain 4. 16 twos, 32. So fine, 0.31 is enough. Okay, and write capital W. This will be your answer B. I think this was a little thinking type of question. Some of you may have had a little doubt here, but I hope it is sorted out. Everybody's clear about this, right?
Yes, miss.
Let us quickly come to question number 8. It's a circuit diagram. So what would be the reading of ammeter? I would like you to draw this. Could you draw this fast and tell me when you are done? Okay. All this is clear in this diagram anyway. What will be the reading of the ammeter? So remember, reading of the ammeter means current in the circuit, because the current is going to go this way and it will pass through the ammeter. Ammeter is always connected in series. So in series it will be the current in the circuit, and then it will split into I1 and I2 in these two branches. What would be our first thing to do? Find the RP. So what will we write? 4.5 and 9 ohm are in parallel. So therefore what we'll say, 1 upon Rp is equal to 1 upon 4.5 plus 1 upon 9. Now I know what you all will do. You all will multiply this and waste time. Don't do that. Write over there 4.5 multiplied by 9 and write here 9 and write 4.5. Understood? And this will give us how much? 13.5, and this upon 4.5 into 9. Okay, now 9 goes 15 times in 135, so this will be 1.5, and 1.5 will go in this. If you remove the decimal, 15 and 45. So can we write it like this? Did you understand the calculation? Did you understand this part, what I've done? Understood?
Yes, ma'am.
If you had to multiply, it would have become a little lengthier calculation. So you understood these are some of the shortcuts for your calculations. Then what you'll say, therefore Rp is equal to how much? 3 ohm. Are you with me? Now, remember in the margin, write V is equal to IR. Make sure that you write your I like this. Therefore, I will be equal to V upon R, but there is EMF here. Can you see that? Internal resistance means this is EMF. In the diagram, write this. Okay, capital E and small r. Write in your diagram. So it will be E upon big R plus small r. Big R means external resistance. Did you see how I write I? There are so many of you who write I like this. That I will look like 1 and you will make a mistake. If you don't make a mistake, the examiner will get confused. So please write I like this, and this will be 2 volt. Big R will be your Rp plus this. So Rp is 3 plus 0.8 plus internal resistance is 1.2. That will give us 2 upon this is 1.2 and 0.8. So that is 2. So 2 upon 5, which is 0.4 ampere. So this is your I. Now here, if you have space, right over there, therefore reading of ammeter. Here itself. So you save your time for writing one more statement. Okay, so this is your answer A. Now what are they saying? What would be the potential difference across the terminals of the cell? So across the terminals of the cell means the PD across this. Means it will be terminal voltage, correct? whenever there is terminal voltage, I have told you to use the formula that E minus V is equal to capital I into small r. Okay, EMF is 2 volts minus V, and that is equal to I is, I'm writing instead of 0.4, I'm writing 2 upon 5 into how much is internal resistance, 1.2, I'm writing 12 upon 10. Are you with me so far? So 2 minus V is equal to, this is 24 upon 5 into 10, okay, which is equal to, now 24 divided by 5 will give us 5 goes 4 times 20, and 4.4 upon 10 it will become. Understood what I've done? This is 4.4, this part is 4.4 upon 10, okay, which is going to give you 2 minus V is equal to 0.44. So V goes that side, so V will be equal to 2 minus 0.44. Okay, therefore terminal voltage equal to V, which is equal to, subtract from here 1 point, how much it is, 54.
Miss,
Huh.
it's 24 divided by 5 equals to 4.8, no?
What did I do? Oh yeah, 4.8 it is. I'm so sorry. Yeah. Plastic surgery. So it will be now 2. Okay, so 1.52 is correct, no?
Yes, sir.
Yeah, 5, 5 8 40, yes. Sorry. Yeah. My eye pains a little bit, then I get a little disoriented. Sorry about that. Okay, so did you understand terminal voltage? Did you understand this phrase? Remember PD across the terminals of the cell. Make a note of it right over there. Note PD across the terminals of the cell means terminal voltage. That is confusing for quite a few students. That's a very normal doubt. So that's why I'm telling you, take care of that. Okay, let us come to the next question. A slab of ice at minus 20 degrees C constantly heated till steam attains the temperature of 120. Draw the heating curve showing the change in temperature with a time. Temperature and time, which means you will have to show the graph with show this a little longer length. Call this as a y-axis. Right over there, temperature. Show the arrow here. Right over here, degrees C. And this is time. And you can temperature with time. Let us have it in seconds. Not a problem. Show the arrow like this. Show this is the origin and show this is your x-axis. Now the minus 20, it is minus 20, so sorry, here I'll have to put minus 20 degrees C here, so 0 will be here. Okay, now at 0 what is going to happen, tell me? There's going to be a sharp rise in temperature. Then here ice is going to start melting, so it will melt like this, correct? And then it will increase the temperature till what temperature? Till 100 degrees C. And as I told you, this is a sharp rise in temperature, but remember water has high acidity, so it will be gradual rise in temperature. You understood how this is sharp and this is gradual? Did you see this angle over here? is more than this angle with the horizontal. Can you see that? So this is the sharp rise in temperature, and the reason for this is right for you to remember SHC of ice is 2.1 joule per gram per Kelvin, which is less. And this one I'm writing in bracket because in your answer this should not include. But your teacher will give you 0 if your teacher sees that this slope and this slope is the same. It should not be the same. Why this is gradual? Right over there, SHC of water. How much it is? Everybody knows 4.2 joule per gram per Kelvin. Then it is going to at 100 get converted into steam, but it will take a longer time. Why it will take a longer time? Because here LV is how much? 2268 joule per gram, and this is shorter because LF means latent heat of fusion is how much? How much? 336 joule per gram. That's why this is shorter and this is longer. In case they ask you the questions, why is this longer than this? Why this slope is sharper than this? I have told you the reasons also. Will you remember? Now for steam, again it will be sharp rise in temperature. Understood? Till it is how much? 120 degrees C. Did you understand up to here? Label the various parts of the graph. So let us call this as A, B, C, D and E. Now in labeling, what will I have to label? What will I label over here? This is ice, correct? This part is where there is water and this part is where there is steam, correct? What else I'll have to mention? There isn't much space here. Then below this or adjacent to this, what I will say, AB is going to represent melting of ice at 0 degrees C into water at 0 degrees C. Understanding of given mass. Tell me what will I write for CD? What will I write for CD? Okay, you are saying that right. Let us write over here, this is O. Let us write over here OA. What will I write? Rise in temperature. Tell me, rise in temperature
of given mass of ice.
Of given mass of ice from minus 20 degrees C to 0 degrees C. Okay, now let us take here BC. What will I write for BC?
Rise in temperature in given mass of water.
Temperature of given mass of water from 0 degrees C to then CD. What will you write for CD?
Boiling of water.
Boiling of given mass water at 100 degrees C to into steam at 100 degrees C. Correct? Then
Yes.
last one is DE. Can you tell what is DE? I don't have space. Can you write DE? What will be DE? Quickly tell.
Rise in temperature of given mass of steam
Hmm.
from 100 degrees Celsius to 120 degrees Celsius.
Very good. Can you write that on your own? Let us look at this. Could you read this in the laboratory?
To measure specific heat capacity of copper, 0.02 kg of water at 70 degrees C was poured into a copper calorimeter with a stirrer of mass 0.16 kg, initially at 15 degrees C. After stirring, the final temperature reached to 45 degrees C. Specific heat capacity of water is taken as 4200 joule per kg per K. What is the quantity of heat released per kg of water per 1 degree C fall in temperature? Calculate the heat energy released by water in the experiment in cooling from 70 degrees C to 45 degrees C, assuming that the heat released by water is entirely used to raise the temperature of calorimeter from 15 degrees C to 45 degrees C. Calculate SHC of copper.
Okay, so there are detailed questions being asked. So we will first make the table. Anytime there is heat exchange, I see last time when I gave you the paper to write, some of you are writing directly without making the table, and then you all have got confused. So please make sure that there is a table. There is water which is added to the copper calorimeter. So you will have the first part is substance, then we'll have the mass, then we'll have the SHC. Please make the columns. Some of you are just not drawing the vertical columns. So please draw the columns T1, T2 and delta T. So first one is copper and 0.02 kg. 0.02 kg at 70 degrees. So initial temperature 70 degrees C is, no, 1 second, what did I do? This is water. Sorry, this is water, no? This much of water is dropped into copper calorimeter. So I'm writing calorimeter. Calorimeter mass is 0.16 kg, initially at 15 degrees C. After stirring, final temperature was 45. So for both it will be the same. And take SHC of water. So water is 4200 joule per kg per Kelvin, and delta T over here will be 70 minus 45. How much is that? 25 degrees C, or it will be Kelvin, and here it will be how much? 30 degrees C or Kelvin. Are you clear up to here? All of you clear up to here? Now
Yes.
what is the A part? What is the quantity of heat released per kg of water? So heat released per kg. per kg of water per 1 degree C fall in temperature. Means it's SHC, no? What is the meaning of this? It is 4200 joules are required for 1 kg to raise its temperature by 1 degree C or to lower the temperature by 1 degree C. Those many 4200 joules will be given out. So the heat per kg of water per degree fall in temperature is going to be 4200 joules. Now, why did they ask this question? Because they wanted to know whether you have understood the concept properly. They are actually asking you to apply the meaning of this. If I talk about the degree fall in temperature, 4200 joules will be released by how much? 1 kg of water to lower its temperature by 1 degree C. Okay, so this was your first part. Calculate the heat energy released by water in the experiment for cooling. So heat released means heat lost by water is going to be mc delta T is the formula. How much is the mass of water? 2 upon 100 kg multiplied by SHC is 4200 joule per kg per Kelvin into delta T is 25 Kelvin. Kg and kg got cancelled. Kelvin got cancelled. 2 zeros got cancelled. 25 into 2 is 50. So I'm going to get 50 multiplied by 42. Now 42 into 5 is 210 and one more zero. So this is the heat energy which is given out or released by water. Assuming the heat release is entirely used up to raise the temperature of water. So what you will say? By principle of calorimetry, correct or no? Principle of calorimetry. I will have heat gained by calorimeter.
Ma'am, do we add at equilibrium or
Just now they have just told the assuming part, no? You could also, yeah, I think it's better to add. You're right. At equilibrium. The thermal equilibrium, this will be equal to heat lost by water. So here I will write M1, C1 and delta T1, and here I'll write 2100 because I've already found it out. Okay, so I'm continuing here after this. For my calorimeter, I will write 16 upon 100 kg into SHC, I'll write C1 into delta T is 30 Kelvin is equal to 2100 joule. So C will be equal to cancel just a 1 0. So 2100 upon 16 into 3, and in the numerator over here they will be joule and denominator kg and Kelvin will go here. Not a direct multiple, right? So 700. Oh, 16. I'm going to split it as 7 into 125. I can see 1,000 there. Are you able to see 1,000 here? Can you see 7 into 1,000? Did you see that? And remember, 1,000 upon 8 is 125. So I'm writing here 16 and I'm writing here joule per kg per Kelvin. Now 8 goes twice and 8 goes here 125 times. Okay, did you understand the patterns of the numbers? Yeah. Now don't divide 3.5 into this to multiply. The multiplication 7 into this will be easier to do. 7 5 is 35. Carry 3, 7 2 is 14. 17 carry 1. 7 ones, that upon 2. Correct? And joule per kg per Kelvin. And now it's easy. 2 4s, 2 3s, 2 7s and 0.5. Understood how to get the calculations done with ease? You have to choose the number patterns and please practice this. Okay, what is this SHC means? It will be in your answer statement. What would you write? Therefore, SHC of copper. Is that what they are asking you? Find SHC of copper. Yes? So that is your answer C. Was it good, bad or ugly? Tell fast. It is good? Yeah? Okay. Now question number 9. Your question number 9 is when thorium decays, then how many alpha and beta particles are emitted? Now this one also is an important question and some of you will get confused for this. So you have to first say that let X alpha, please write fast, and Y beta particles be emitted. And double tick mark this question because this is an important question. Okay, so your reaction will be here. This is thorium and it is thorium 238 and what is this number? 90. Oh sorry, it is written 238 thorium and here 90. Okay, it is going to become bismuth 222 and 83. Okay, now X alpha particles means alpha will be helium 42 and plus Y beta particles means beta 0 minus 1. Up to here everybody should have no problem. Now if I take the top number, it is called as the mass number. So I will say mass number is conserved, which means 238 will be equal to 222, this number, plus how much of X? 4X, plus how much of Y? 0Y. Correct? Now take this 222 this side. So you will have 238 minus 222. How much is that? 14? No, sorry, 16, no? What am I doing? 38. 8 minus 2 is 16, right?
Yes, ma'am.
So 16 is equal to 4x.
X equals to 4.
X equal to 4. Then what you will say? X equal to 4. So now you will say atomic number. Atomic number means the number which is the lower number is conserved.
90 equals to...
You have to write this also, bacha. Don't forget to write the statement, okay? 90 is equal to 83 plus how many x's?
Plus 2x.
2x
Minus
and
y.
minus 1 into y, correct?
Yes,
So 90 minus 83 is equal to 2 into 4 minus y, correct? How much is this? 7 is equal to 8 minus y.
y equals to 1.
Huh. So y equal to 1. Therefore, 4 alpha and 1 beta particles were emitted. Understood how this is to be done? This is an important question. Please remember. Now what are they telling you? Name the technique used to estimate the age of old trees, that is carbon dating. Name the isotope that forms the basis of this technique. It is carbon-14. This was pretty simple. Now uranium is available in two forms. Can you read that while I drink water?
Uranium is available in two forms, uranium-235 and uranium-238. Which of the following isotopes of uranium is more fissionable?
So this is a direct question. You know which one is. Give major difference between fission and fusion is learning type. Give the reaction of nuclear fission using the isotope in A. So A, which one is fissionable? You have to learn that reaction. So this is all learning type. What is this? Refrigerator converts 100 grams of water at 20 degrees C to ice in 35 minutes. Calculate the average rate of heat extraction in terms of watt. And here again you will make two columns because we have the fridge and we have the water. The power is going to be the average rate of extraction, okay, and they are telling you the time is taken. It is how much? 35 minutes. So 35 into 60 seconds. For water, remember this is requiring the schematic diagram. Now mass is equal to 100 grams, which is good, but we will have to have water at 20 degrees C. First will become a water at 0 degrees C. Then it will become ice at 0 degrees C, and then it will become ice at minus 10 degrees C. So this will be your Q1, Q2 and Q3. This is change in temperature. We will use MC delta T formula. This is change in state, write MLF. And this again change in temperature. So this will be MC delta T1. Understanding? Okay. So you will have the heat extracted by the fridge mistake. Silly mistake I made. Instead of letting the children inside, excuse me, is equal to heat lost by water. Okay, this will be P into T, and here it will be MC delta T plus MLF plus MC delta T1. Now MC delta T will be equal to 100 grams multiplied by C. I'm taking in CGS for water is 4.2, so that is 42 upon 10 into what is the delta T? What is the delta T for water here? 20 to 0 means 20, correct? Put bracket for this. Here again mass 100 and latent heat of fusion is given as 336. Plus it will be 100 into, this is your ice. Ice SHC is given 2.1. So I'll write 21 upon 10 into how much is delta T? 10. So let us cancel the zeros here, and P into 35 into 60 is here. This will give us 8400 plus 33600 plus it will be 2100. Okay, so if you add them, how much you get here? 21. So 10500. 10500, no? So this is my rough work. Okay, so I'm getting P is equal to how much? 441, no? 44100, correct? That divided by 35 into 6. Actually, if you do 35 into 6, how much are you getting? 6 5 is 30. Never mind. 35 into 60. Cancel this 0 and 7 should go here. So 7 5s, 7 6s 42 and 7 3s 21. 3 goes twice, 3 goes here 21 times. Now can you see 21 upon 10? Yeah, can you see that? So 2.1 watt. Okay, so we have finished with this. So main important thing over here is whenever there is change of state, make sure that you are drawing the schematic diagram. If you do not draw the schematic diagram, your teachers will not do this. They will do it mentally and you will get confused. Okay, so ideally everything depends upon how well you understand this, the change of state under the change in temperature. Okay, so we have understood how to solve these papers and we stop there for today.